Welcome. My name is Carl Sjostrom, and in this episode of Getting Executive Compensation, we're going to be looking at statistics. This is an episode that is designed for YouTube. It's not for the podcasts, and that is because we need some visual aids to get through this rather dry subject of statistics. We're not going to go into anything very complicated, we're just going to cover the basics, but it is hopefully going to be helpful for those who need to make decisions and understand what compensation data is trying to tell them. So, statistics. Why do we use statistics? Well, here on the right hand side, we see a sample. This is the universe that we need to understand in order to make a decision around compensation. It might be that one of these individuals is our individual, or we have an individual employed who's not on the list, or it may be that we're about to recruit someone, or we're just trying to understand what's happening out there. So we try to find a benchmark. And we've tried to find the benchmark because understanding and knowing what everybody is paid is unlikely. We may be lucky. So, some positions, like chief executive positions, we can go out and find publicly available data in a number of countries, not in all. But for it to be truly up to date and really correct, we are likely to need to get companies to supply the data to a survey company, and that survey company needs to treat that data with confidentiality in order to be credible, because otherwise people won't give them the data. And in order to do that and to give us as good a picture as possible without giving us all the specific individual details, we get fed back benchmark levels in order to represent how much the market pays. And the benchmark levels come from statistics. So if we look at our sample, here we have 11 individuals. So Amy, Bob, Chris, Daisy, Eve, Fred, Gus, Hank, Ingrid, Jim, and Kim. And they're all paid different amounts for a salary, but for our purposes, they're doing exactly the same job, and they're entirely comparable. And we believe that these are the individuals that are the market. So to find statistics that are relevant, we usually use the average to represent what is typical. It's not just something we do in compensation. And here we have ordered our sample not in alphabetical order any longer, but in size of salary order, with the largest at the top, that's Lucky Jim, and poor Amy at the bottom, who is paid quite a lot less. The average we find by having these 11 observations, and the typical one we use for compensation is the median. And the median is found by finding the middle. It's the middle point in an ordered set of observations. And in this case, since it's 11, the middle point is the sixth one, and that's Bob, and Bob is paid 130. So the median is 130. The other average that can be used is the so called mean average. What we do then is we take the 11 observations and we add up all the salaries. And that comes in this case to 1,724. You'll just have to trust me on that. And the mean, and this is usually what we think of as the average, the mean is found by taking 1,724, the total, and dividing it by the number of observations, 11. So 1,724 divided by 11 gives us 156.7, roughly. And that's the mean, and the mean is therefore found in between Bob's and Gus's pay levels. It's slightly above Bob's because we have in this sample some people who paid quite high, namely Jim and Ingrid. Jim and Ingrid are pulling up the mean so that it is higher than the median. We do not have what's called a normal distribution in our sample. It is slightly skewed. So that means if you think a normal distribution, that's your typical bell curve. It looks like a very smooth hill, and this hill is tilting, skewed slightly towards the upper end, so we get a mean that is higher than the median. And this is the reason why we usually use the median, because the mean is very quickly influenced by extreme data points at the top or the bottom, whereas the median ignores those data points. It just finds the one that's in the middle. So let's take this one step further. We do often speak about more than the median when we are looking at compensation. You'll hear people talk about the quartiles, the upper quartile, where people who are highly paid are, or the upper decile, which is where people who are really well paid are. And we also hear about percentiles. So just a quickie on what does that mean? Well, percentiles are, instead of dividing the sample into two, like we did with the median, we divide it into 100 slices. So imagine a cake where we make 100 slices. It isn't the same as percentages, it's slightly different. Percentiles look at space. So it is like that cake divided up. It actually takes from outside at the top to outside at the bottom to divide it all into slices. And that means that the typical formula to find the percentiles that we use is n plus 1 times the percentile we're trying to find, expressed as 0.121. So if we're trying to find the median, we are trying to find the 50th percentile. And we find it by taking n plus 1, so 11 plus 1 is 12, and multiplying it by 0.50, which is the 50th percentile, and we find that the product of that is 6, which is Bob again at 130. If we're looking at deciles, we wouldn't divide our cake into 100 slices, we'd divide it into 10 slices. The upper decile being where 90% of the sample is paid less and 10% of the sample is paid more. Similarly, with quartiles, we divide this cake into 4 slices. And the people who are in the upper slice, if you're at that point, the 75th percentile point or the upper quartile point, 75% of the population is paid less and 25% is paid more. In this case, the upper quartile, that's Kim. She's paid 220. And the upper decile, as it happens, is somewhere in between Jim and Ingrid. Now, having done the percentiles, deciles, quartiles, and median, let's look at how medians can also have issues. The simple median. Here's our sample again. We have now added 3 things. First, we've identified the companies that our sample are employed in. And here we are in name alphabetical order again. We've also added a bonus, and we've added up the salary plus the bonus into a total compensation number, often referred to as total cash, but let's call it total compensation. So, bear with me. Let's reorder this sample first for salaries. And we've already done this. So we order the sample for salaries and we find again Bob at the median. Now, what about bonuses? What's the median? What's the average bonus, median bonus in this sample? If we order the sample again, according to the size of bonus from the largest bonus, which has been earned by Fred, got a 200 bonus, and to the smallest bonus earned by Kim, she only got 10. Well, that's Amy. Amy is the median. She's bang in the middle. Amy's employed by Gold, and she got a 25 bonus. We look at total compensation. We order the sample again from the largest. The highest pay in the whole sample was Fred from Platinum, And the lowest paid in the whole sample was Amy from gold. Median is Hank, employed by copper. He got 220 total for the year. Now, what's important about this, if we look at this picture, is that if we take the median for salary, which is Bob's 130, and we add Amy's median for bonus, which is 25, we get 155. That is not the same as what Hank received at Copper, which was 220. And the moral of that story is you cannot add median bonus to median salary and get a guess that is valid for median total compensation. And that is because the compensation mixes here are very different. We get some, like Fred at Platinum, he earns one of the lowest salaries at 99, but a huge bonus, 200, and gets the largest total compensation. And then we get some, like the Copper guys, they seem to be earning high salaries and very low bonuses, but they make around the median a total compensation. So, very important, do not add statistics to statistics in order to get a third statistic. If you use the mean average, you might get there, but if there's a skew in the sample, it will not work out. Then let's return to our sample again, and we'll drop the bonus and the total compensation for the rest of this. The point has been made. But let's just look at the salaries again. So we've reordered the sample from highest to lowest salary. And we've got Bob from silver at the median again. Now, let's just look at the companies they're all employed by. And we notice that there are 7 companies here. And Copper employs 5 of our 11 individuals. The other companies just have 1 individual reported to the sample each. That means that Copper potentially is dominating the market a bit, could have a very significant impact on levels. And if we feel that Copper shouldn't be overrepresented in the sample, we could consider a median statistic as well. That means take the median of each company, which is easy for everybody but Copper because that is the individual who is there. The median of one individual is the one individual. But for Copper, we could then find a separate median, which is 220, as it happens, represented by Kim. And we can find the median of medians, and that is Eve at 100. Another angle to this story is that if Copper was to send in a representative individual like Kim and not submit the rest of the data, we would have a sample of 7 data points and the median would be 100. But that would not give us a proper view of the true market if this 11 individual sample was the true market. We would be 30 below where we needed to be if we were searching for that information. And we can further illustrate this by taking our sample again and plotting it. And some survey companies will provide you with plots of where data points are in the market. At least they'll give you an indication through graphical representation. So if this was our sample, we see here that there's one dot in the middle, which isn't actually very near the 2 remaining groups. There are effectively 3 groups here, and one is a single dot, and that is Bob from silver. So actually, our representative data point may be misleading. It may actually be the one data point that doesn't represent a market. Because if we have a situation where either it's a mistake, so say Copper has been submitting data which they have matched to the wrong level, or they are simply doing something that is different, and we would rather just be comparing ourselves with companies that are in the circled in the bottom left-hand corner, then maybe we should create a select group that excludes copper. And our data provider could advise us around that. It could also be that actually the copper data points are the ones that are relevant for our purposes. And again, the data provider might be able to advise us around that. It's always difficult for a data provider, and it's essentially impossible for them to just remove one company. Because if we've just removed one company from our sample and asked the data company to run it again, yes, we would get a different median, actually a median of 99.5 for the six companies that would remain. But we would then be able to identify from the statistics how much impact the copper removal had, and we would gain perhaps a bit too much insight into single companies' pay practices, and that would threaten the integrity of the data. But nevertheless, bear with me. What this shows is that there are often different markets within the market, if you like. In the data sample, there are often clusters. And if you ask the data company, they can help you understand the dynamics in this information and maybe provide you with a more relevant sample to match against. It could also be that all the other companies, except for copper, failed to submit enough data. They submitted representative data points. And here we have a case where we have managed to get the rest of the data from them all. And as it happens, they all have 5 employees. And as it happens, they all pay at the median 220, just like copper. So that's nice. So we have a median. Everybody is paying at the median, generally speaking. But copper then realizes that they have a cost position that is much higher than a lot of their competitors. They seem to be unable, and I've been through this in real life with clients, where company realizes that they have a very competitive pay policy. They pay against the market at the median or even better, but there are competitors who have a better cost position but seem able to attract top talent by paying them much more than, in our case, copper can pay according to their policy. And if we look at this chart, we see an indication of why that is. So these companies all pay at the median the same, but some of them have significantly lower costs. And if you look at gold, that's a clear example. Gold pays at the median the same, but the reason they can attract much better talent and pay them so much more is because they also pay people much less. They discriminate much more within this position between individual performers. And this is something to consider, that if you have a pay policy that is to pay in the middle of the market, that doesn't mean you're necessarily competitive. The dynamics of the market may be very different. I hope this has been helpful. My name is Carl Sjostrom, and thank you for listening.